Hi guys, today we are going to go through the notes for section 5.4 from your book, which is the sum and difference formulas. At the top of your page, you see all of the sum and difference formulas. We have different formulas for sine, cosine, and tangent. So you will only ever be doing this with sine, cosine, and tangent. So basically, whatever formula you need comes directly from whichever function you are trying to use. So these two will use the tangent functions, these two will use the sine and cosine functions. So the very first one is sine or cosine of 75 degrees. So in order to use these formulas, we need to find two angles that we know exact values for. So we know exact values for anything that comes from 30, 60, 90, 45, 45, 90, and the whole unit circle. So our basics are 0, 30, 45, 60, 90, and then we go around the circle in that fashion. So actually, I think it would be really good if we kept going with this. So after 90, we would have plus 30 would be 120. And then we would have 135. And then we would have 150 and 180. That would be the top half of the circle. All of these would be helpful degrees because they come from 30, 60, 90, or 45 degrees. And then as we go back around, we have 210, 225, 240, 270, 300, 315, 330, and 360. So this is an excellent list. These are all of the degrees that go around the unit circle that we've been using. So 75 degrees, if we can piece it together from any of these, then that means we can use one of the formulas. So 75 is 30 plus 45. So I'm going to rewrite cosine of 75 as cosine of 30 plus 45. 30 plus 45 is 70, so I'm not changing anything there. I should put in my degree signs though. So this is cosine, and I'm using addition. So I'm going to use my sum formula for cosine. So cosine of A plus B equals cosine of A times cosine of B minus sine of A times sine of B. So I've got cosine of 30 times cosine of 45 minus sine of 30 times sine of 45. Literally using a formula, that's all. So now cosine of 30, cosine of 45, sine of 30, and sine of 45, we need to know based on our triangles or our unit circle. So 30, 60, 90, if I have the 30 degree angle, I've got 1, 2, 3, I always do that, 1 root 3 and 2. Cosine of 30 would be root 3 over 2. Cosine of 45 comes from 45, 45, 90. So that would be 1 over root 2. And then I need to do sine of 30. Sine of 30 would be 1 over 2. And sine of 45 would be 1 over root 2. So when I do this, I end up with root 3 over 2 root 2 minus 1 over 2 root 2. You really need to know how to use fractions in order to do this. Multiplying fractions, multiply the top, multiply the bottom, multiply top, multiply the bottom. Now when I subtract, I need a common denominator, which these happen to have. So root 3 minus 1 over 2 root 2. Now this could be an answer, but it's not simplified because I don't want to have root 2 in the bottom. So I need to multiply by root 2 over root 2. And when I multiply by root 2 on the top, I end up with root 6 minus root 2 over. And then root 2 times root 2 is root 4, which is just 2. 2 times 2 is 4. So this is actually as simple as it gets, and that is your final answer. So we can say cosine of 75 degrees equals root 6 minus root 2 over 4. Now you cannot combine those two values because you can't combine radicals unless they have the same number underneath. So root 6 minus root 2 just stays, and that's your answer. So every single one of these, I'm going to try and find two values from up here that when added or subtracted can get to this value. So I think it would be important for me to show you a tangent one because that formula is a little bit different. So let's go jump down to tangent of 165 degrees. So 165, I'm going to work with something up here, right? So maybe you're thinking, you don't want to think of something that's too close to 165. It's only 15 away from 180 and it's 15 away from 150. So that's a little bit too close. You might be thinking 135 plus 30 degrees. That would be good. Or maybe you're thinking 210 minus 45 degrees. I think that would also work. I'm going to do 135 plus, I'm going to do 135 plus 30 degrees. So I'm going to change this into tangent of 135 plus 30 degrees. So I'm going to use 135 as my A and 30 degrees as my B. So tangent of 135 plus tangent of 30, I'm using this formula up here. So I end up with tangent of 135 plus tangent of 30 over 1 minus tangent of 135 times tangent of 30. So now 135, I need to figure out what that is. And it comes from a 45-degree angle because 135 is equal to 180 minus 45 degrees. So that would be in the second quadrant. But since it's using a 45-degree angle, I would use my 45, 45, 90 triangle. So this would be negative 1, 1 and root 2. The hypotenuse is always, always, always a positive value. It's the legs of the triangle that change into negatives depending on where it is. So this is negative, positive, 45-degree angle. That means that's root 2 for your triangle. So the tangent of 135 is going to be 1 over negative 1, so that would be negative 1. The tangent of 30 degrees, if I have 30 degrees here, across from that is 1, and the hypotenuse would be 2. So I would have plus 1, and the other leg would be root 3. So I'd have plus 1 over root 3 over 1 minus negative 1 times 1 over root 3. So now I have to do some fraction work. In order to combine my top two fractions, I need them to have a common denominator. So I'm going to change the top there into negative root 3 over root 3 plus 1 over root 3, just to combine it. And I'm going to make the bottom nice by multiplying these, which ends up being, if I multiply these, it turns into a plus sign. So I end up with root 3 over root 3, because 1 changes into root 3 over root 3. And then plus, this would be 1 over root 3. So when I combine the tops, I have negative root 3 plus 1 over root 3 over root 3 plus 1 over root 3. So if I keep change flip, I'm going to do negative root 3 plus 1 over root 3 times root 3 over root 3 plus 1 These cancel out. And I end up with this. That is not simplified though, because I can't have a radical on the bottom. And in order to get a radical out of the bottom, when you have a binomial like this with a plus or minus, you actually have to multiply it by the conjugate. So I need to multiply by root 3 minus 1 on the top and the bottom. On the top, that turns into root 3 times root 3 is just 3. So that turns into negative 3 plus root 3 plus root 3 minus 1 over 3 minus root 3 plus root 3 minus 1. So on the top, negative 3 minus 1 is negative 4 plus 2 root 3. On the bottom, we have 3 minus 1, which is 2. I'm almost done. If I divide both of these by 2, I end up with negative 2 plus root 3. Boom. 4 divided by 2 is 2. 2 divided by 2 is 1. And I leave the root 3. There is a lot of radical work here. The only way you can do this is if you understand fractions, radicals, algebra 2 concepts. One of the big ideas that you would have to be able to do in these tangent ones is multiplying by the conjugate here. That's a big ticket item, okay? That has to do with simplifying. If you can get to here, that's excellent work. This is an algebra 2 step, and you want to get better at that, okay? So that is all just using the formulas. I'm going to do one more video about how to do this when you're given values rather than increments.